these test tubes, and these test tubes indicate precipitates. See, these suspended particles settle down and these are called precipitate, and the color of precipitate is yellow. In similar manner, this tube also contains precipitate and the color of precipitate is white. You can see this is again a test tube containing precipitate, but this is cream color. This test tube contains precipitate and this is light yellow color. So today I would like to tell you story behind these colors of precipitate. Basically, this is ions identification and we are talking about anion identification. Anion identification means halide ions, chloride, bromide and iodide. To test any ion, we always use reagent. So I would like to perform the practical to show what will happen when we use a reagent. So to identify anions, chloride, bromide and iodide, we use a common reagent which is called silver nitrate. So see, you can, when I add few drops in this test tube, in this test tube and in this test tube, you can see a change. See, the precipitates are appearing. See, a white precipitate, a cream precipitate, and this is a light yellow precipitate. So if there is a white precipitate, that shows chloride. If there is cream precipitate, that shows bromide. And if there is a light yellow precipitate, this is iodide ion. Well, we have another reagent that gave us a visible bright precipitates, and see, this is lead nitrate and we use it for iodide ion. See, a bright yellow precipitate. So I will tell you chemistry behind these anion analysis. Thank you very much. And we get yellow precipitate of iodide. We get yellow precipitate cream precipitate for bromide and yellow precipitate for iodide. And the reagent which we use for this anion analysis is AgNO3 aqueous. And here we use our reagent which is known as lead nitrate aqueous. So now, what is formed in this test tube? First of all, we will talk about this lead nitrate. When we add into this solution, what we will get in the form of yellow color. So what is yellow precipitate? Actually, it is PbI2 solid. And now what is the chemistry behind this reaction? You have a solution of sodium iodide aqueous in a test tube, and when you add a reagent which is PbNO3 you know that all nitrates are soluble, so this lead nitrate is a soluble solution. And when we mix two soluble solutions, we get one insoluble, that is Pb I2 solid plus and we need to balance this equation since 2 is written, so we need to write 2, and because sodium is 2, iodine is 2, iodine here is 2, iodine I is 2, so we need to write here 2 sodium iodide. This reaction is called ionic precipitation. This whole equation, this reaction which I have in this test tube is called ionic precipitation. These ions precipitate out lead ion and iodine. So how can we write the ionic equation for this? We can write ionic equation for lead iodide. It's very simple, and just write PbI2 here and write their ions Pb2 plus aqueous and 2 iodine aqueous. For all ionic precipitation equation, we don't need to write spectator ion and whole equation. We just pick up the solid and then write the ions, because all rest of the ions are aqueous and they can be considered. Thank you very much. Now we will talk about these chemistry of these 3 reactions in which we get precipitate, white, green and yellow. White precipitate, green precipitate and yellow precipitate. What happened in these test tubes? So yellow precipitate, which you can see here, yellow precipitate is due to silver iodide solute. Salts of heavy metals are insoluble. You need to remember. So this is heavy metal, and when these ions react together and they make silver iodide, insoluble, that is why it's settled down. White precipitate of silver chloride, green precipitate settled here, and green precipitate of AgBr. Now I will explain these equations for silver chloride, silver bromide and silver chloride. When you add, what is the reagent for the reaction? You have sodium iodide in test tube. You have sodium chloride solution, aqueous in a test tube, and you have sodium bromide aqueous. As you know, all sodium salts are soluble, so they are soluble. And you add a reagent which is used to identify halide ion. AgNO3 aqueous, AgNO3 aqueous, AgNO3 aqueous. Now you know what is going to happen. This silver ion react with iodide ion, this silver ion react with chloride ion, this silver ion react with bromide ion, and there is a difference of solubility which make it, this is insoluble and this insoluble settle down in the form of precipitate, and you get in this case you get AgI in this case you get AgCl, in this case you get AgBr. And second thing you already know, you get sodium nitrate H, which is insoluble, which is soluble. So NaNO3, which is X. So I'm sure you can write an equation for these reactions